So this is a good list of how you know when it's math. Math is about patterns. It's about possibilities. It's often about numbers, especially the math that you do from age 5 up through about the first semester or two of college, right? It's almost all numbers and some geometry, right? Shapes and stuff. And some variables, but those variables are just placeholders for numbers most of the time. What kinds of numbers? And so at every one of these steps was mind-blowing to you the first time you learned it, right? As a learner of mathematics. What are we gaining at each one of these steps? When I go from the natural numbers to the natural numbers with 0, what can I do here that I couldn't do there? Any ideas?
Represent nothing.
I can represent nothing. I have an idea, a concept of nothing. I've gained now a number which I can add to other natural numbers. And what happens when I add 0 to other natural numbers? I get the same. Nothing happens, right? That's why it embodies nothing. When I add it to something, that something doesn't change, right? So 0 embodies nothingness, and we don't have that when we're only counting starting at 1. What do we gain when we go from here to here, when we're suddenly working with integers? We gain the negatives. What can negatives do for us? I heard it. We can subtract, right? We can add in these first two systems, right? If I add 2 natural numbers, I'm going to get another natural number. If I add 2 whole numbers, I'm going to get another whole number. But if I subtract 2 whole numbers, I'm not necessarily going to get another whole number, right? Not until we get to this next step at the integers. Now, when I have the negatives, now I can add and subtract anything from anything, right? Any integer, subtract any integer is going to give me an integer, for sure. So we've won something with that step. What else can we do with integers besides add and subtract?
Divide.
Well, not quite. We can't quite divide. We can multiply, right? If I take an integer and another integer and I multiply them, the result is an integer. But what I cannot do with every pair of integers is divide. 3 divided by 7. Not an integer, right? So that necessitates the next step. Right? Now we're at the rationals, and we can do everything, all of the above, and we can also divide. Any rational divided by any rational will give me a rational. Well, there's one exception to that rule. What division can we not do in the rationals? 0. We can't divide by 0. So let's get that important caveat. Divide except by 0. And then we have these last couple of steps, from the rationals to the reals, from the reals to the complex. And because we're not going to dwell in real and complex land very much this semester, well, let's not talk about those last couple of steps. I'm going to leave that for your analysis professor to do. What I like to say that we're doing here is we're just adding more structure. When a mathematician talks about structure, what it does is it gives us possibilities. It gives us new things that we can do with our mathematical object of choice they weren't able to do before. And once we decide that we have enough structure to solve the problem that we need to solve, then we can work with that minimal structure. There are some problems that we might want to solve in mathematics for which natural numbers are enough. For example, if I'm just looking at, if I have a couple of sets and I want to count the number of elements in those sets and those sets are non-empty, well, the natural numbers are enough for that. Right? But if I want to do anything more sophisticated, I might need one of these more sophisticated systems. So mathematics, I think, something that maybe spans everything that's listed up here, is a study of structure. Like, what are the possibilities? What can we do with the objects and the actions and the transformations and the things that we define, the things that we put in front of us? What can we do with them? And what relationships do they have one to another? Those are examples of what a mathematician would call structure.